right. I think I'm not sure if the poll stays in your way or if you guys can get that out of your way yourself. If that's in your way, just go ahead and throw a comment in and we'll actually end the poll instead of just minimizing that. But hi, thank you for taking the time to join us today. You've heard of Graphy before, and today we'll be focusing on the implementation process and some of the material property advantages. Um, We're looking to bring on more Graphy KOLs as time goes on. Graphy is looking for USA KOLs. And we will be planning another Graphy webinar with a clinical focus in the coming month or so. We want to do this webinar now so that there's time for clinics who are ready to purchase equipment to take advantage of the year-end tax benefits. After this webinar, if you're interested, we can provide content with a clinical focus, as well as a database of relevant peer-reviewed articles to deepen your clinical understanding. At the end of this webinar, there's a short survey that is meant to help us understand your needs. So please provide any and all feedback possible. Ask questions anytime in the chat, and our mediator, Paul Wilkins, super handsome fellow, has been 26 years of experience in orthodontic industry. We'll work them into the discussion, and we'll have also a Q&A at the end. So feel free to ask me to slow down, as I tend to get a bit excited when I'm talking about 3D printing. My name is Mike Gordon. I have been in IT my whole life. Been in IT my whole life. Started providing small business IT in 2008 with my passion for 3D printing starting in 2012. And just a few years back, I was approached, or I made a connection with a few GPs in my local area, and they wanted to implement 3D printing in their clinics. And so, I worked with them to bring on that technology. And we quickly realized that there was a huge learning curve to be able to do it successfully and with the least amount of limitations. So we sort of identified a problem with a new type of need for a new tech-savvy 3D printing expertise from the in-clinic perspective. And that's what 3DNA was sort of born to provide. So we provide clarity from our past successes with a physics-driven problem-solving mindset. And we're committed to finding consistent solutions for clients. So that's our mission, is essentially to empower clinics to adopt their choice of 3D printing workflows while providing comprehensive support from the clinical perspective, or from the in-clinic perspective. So today in the webinar, we're going to go through some product understanding again better the material properties of this and why they're so exciting. We're going to talk about the cost analysis and cost savings that it could imply for your clinic. We'll talk about the equipment and lab setup that you need in order to provide this service, and also the challenges and sort of the difficulties of the design and staff training that we should be aware of when we talk about doing this, and then the advantages of what all of that work will allow you with the same day aligner delivery capacity in your clinic. And then we'll finish with pricing and support and how to get started. So why we want to talk about Graphy specifically, again, the material properties are absolutely incredible. They have much better ability to stay within the optimal stress range or the force range that you want for a longer period of time. The major reason for that is the shape memory function of the material, wanting to return back to its printed shape. And it's formulated to do that at the optimal tooth force, or the movement force, at body temperature, right? Human body temperature. So that was one of the major aspects. Also, Graphy's material is incredibly biocompatible. So it's important to know that that was taken absolutely very seriously. That was the first concern from the get-go. It has the lowest cytotoxicity of all the PET-G sheets. Like it's basically as low as it can get in terms of cytotoxicity, and therefore the best biocompatibility rating. The other big advantage is the ability to fit into every little aspect of the surface area that you can take advantage of, because of the ability to go straight from your intraoral scan to a digital design tray that's 3D printed and made to fit exactly in that contour. Whereas in the past, of course, with thermal forming of any kind, either vacuum or pressure forming, you just can't quite get that amount of fit. And then, of course, in order to be able to, take the tray off and on, you would need to block out the undercuts. And with graphite, you don't need to do that because over body temperature, it's extremely malleable and it's able to slip over the teeth. And then as it returns back to body temperature, it again wants to just apply that consistent around 1.5 Newton force on average. Um, and you can just take advantage of all of those undercuts for extra surface area, right? So in aligners, most of our force is coming from surface area, not the modulus of the material itself, right? That's been the case since the beginning. So increased accuracy from all of that material properties advantages means that throughout a case plan, from the beginning to the end, at the end of each step, if the teeth haven't quite gotten all the way to where they were meant to be, that tends to compound as the case continues. And with graphite, they've found that it's by the end of a case, it tends to be around 3 times more accurate in terms of where the teeth actually are compared to where that step thought they'd be. Another huge advantage is your margin line control, as well as the thickness control of the aligner itself. So wherever you're going to have a high stress situation where there's a lot of pull or push forces, or it's on the occlusal surface and is going to be chewed on and ground on a little bit, you can add thickness there. But the margin line control means that you're able to increase the optimal forces incredibly by moving from a scalloped margin up to all the way to a straight extended margin, right? So that is a massive advantage with graphite, and that margin line is printed in as opposed to trimmed in. So it's very, very accurate, and it really almost never will have any sharp edges and things like that, which can also be a big concern. So graphite does recommend the first step to continue with a fully scalloped margin so that the client can get used to having that aligner in their mouth and don't have any abrasion or issues with compliance from a comfort perspective. And then as you move to the next steps, you can move that margin line up and increase that your sort of ability, the forces involved there. So that all translates to having really efficient tooth movement and up from the max 0.25 movement per step that we're used to with traditional aligners. A lot of the KOLs are doing 0.35 per step, and graphite has had some experience going all the way to 0.5 mm per step. That might be, you may be doing longer term, like 2 to 3 weeks per step, for example, since the material can last a lot longer in the ideal force range as well. Another big advantage is reduced attachments. So reduced attachments mean a lot less chair time for you, and it means less etching for the patient. And it also, because you're not needing those attachments because of that full tooth contact that you're getting from this material. So that's very exciting. Graphite is an amazing product in terms of its flexibility to integrate within your practice. We'll talk about it a little bit more later, but it's completely flexible with any planning software that you're using that can export models. So pretty much mostly all planning software. And then the flexible planning itself. So instead of planning an entire case at the beginning, where you sort of need to predict all the phases that you're going to go through and that they're going to move the way you expected them to, with graphite, they recommend that you do 8 trays at a time, since that's how many trays the printer can print in one go. Which means if you're doing upper and lower, you're planning 1 to 2 months if you're doing a 1 or 2 week step, or if you're doing longer steps, even more. So that gives you a lot of control, and that's a huge advantage as well. Immediate delivery, what does that do for your practice? And that compared to, like, let's say a 2 to 3 week or 1 to 2 week turnaround time, depending on where you're located, sometimes even more. Increasing patient acceptance is a big advantage there. And then finally, enhanced patient compliance. So with lower, more consistent force, more comfort for the patient, it tends to increase patient compliance. And again, the ability to take the aligner in and out without the need for a chewy or a munchie or whatever is a huge bonus as well. So these are all awesome additions to why we should be excited about graphite.
We do have a question, Mike.
Sure. Yeah.
From Danny. He wants to know which margin design is better.
Yeah, so there's not, like I think that's a clinical question for sure, and it's a case by case basis situation. But essentially, the maximum force will always come from a straight extended. So essentially, the more surface area you have, the more force you can apply, and it's super important to know that with aligners, that's where all of your tooth force is coming from. Is not the modulus of the material, since plastic is actually not very rigid. It's really because you're touching so much, you're making so much contact with the teeth and with the gingiva. So straight extended is where you're always going to have the most force. But do you always want the most force? Maybe, maybe not. The other thing is if you're not doing a huge amount of movement per step, then it won't hurt to have straight extended all the time, maybe, and that will kind of give you the most accuracy. But if you're doing a lot of movement per step, then having a fully like straight extended margin might cause a little bit more discomfort for the patient. So again, those are clinical questions that I'm not the right person to totally answer, but from what I understand, that would be the answer. So moving on, let's talk about cost comparison between traditional aligners and 3D printed aligners, in our case, Graphy memory shape aligners. 1 kilogram bottle can print between 100 and 125 aligners. I think 125 is actually quite conservative. So we say about 115 aligners per bottle, which comes out to about $5.50 of material cost per tray. And then you need to calculate labor on top of that, right? In terms of other ways of saving money, it's extremely cost effective because your case planning, like essentially kind of doesn't matter if you're doing a refinement case or a change of a case or a very complicated case that's coming in different phases. The workflow ends up being very similar in terms of the actual design and production of the aligners. So that's a very cost-effective change compared to the traditional method of needing to reorder and wait. We also obviously are minimizing shipping. You're not shipping per client anymore. You're shipping per bottle. So let's say like 4 to 5 clients. You're hugely minimizing environmental impact because you're not printing models. Maybe you weren't printing models in clinic if you weren't doing in-house production, but the lab is making those models. So one way or the other, we're saving a lot of material in that sense. Also, there's a lot of waste in when you're thermoforming a PETG sheet of whatever kind. Most of it is actually wasted, right? And then obviously there's a huge amount of labor that goes into all those steps. So that brings us to our next thing, where labor efficiency is a huge advantage here with direct print clear aligners over the traditional method. Because you're adding equipment into your clinic, there is depreciation to consider. So that's a cost that maybe you didn't have incurred before. But if you say that the equipment's going to last you 2 years, since that's sort of a typical thing in accounting, if this is based on if you were doing 1,500 cases a year, so it'd be like 20 cents per tray at 1,500 cases a year. So pretty minimal depreciation costs. And then there's really no reason to think that your equipment would only last you 2 years. So it should be even better than that. Increased patient acceptance is something that we can expect from this immediate delivery is, I think, a big part of it in the US, especially where we have this sort of like lifestyle where we expect a lot of immediacy. But also the fact that you can convey that there will be fewer attachments, less discomfort for the patient. All of those things can drive up patient acceptance. And the other thing is patients who experience something new and more comfortable, and let's say you show them or you explain to them that you're printing this in-house with a 3D printer. With a lot of these 3D printers, you can also display them, or with this 3D printer that we'd recommend in this workflow, it's a really nice looking printer. And it also has a air filtration attachment you have to buy that additionally, but it allows for being able to sort of expose the printer in your clinic. So those are things that can definitely increase your bottom line. So let's talk about more specifically how to figure out what it's going to cost you per tray with this and compare that with your traditional method. According to LMT magazine, as of last month, the cost per tray is $56 on average from a traditional lab. If you're doing 30 trays per case, so if it was upper and lower 15 steps, and you did 1,500 cases in a year, that would come to just over $2.5 million for your lab bill. With direct print, you're looking at, so if it's 600 on the high end, again, it's $620 a bottle. That's if you're not buying in quantity, if you're only buying one at a time. And you're able to do 115 trays per bottle. That comes to about 392 bottles of resin for the same number of aligners. So 242,000, just over 240,000 in material costs for the year. And then you need to calculate your labor costs per tray. So here we have it set for $10 per tray. And we'll show you a little bit why. I don't want to spend too much time on this, but if you guys have any questions on this, please do feel free to push this a little further. But employee labor calculation, it's 5 minutes per tray of actual like physical time required for the production of your trays by an employee. So that comes out to about 12 trays per hour. If you have a $30 an hour employee, that's $2.50 per tray. One thing you always want to account for is how you're going to handle the if you're implementing this in your clinic, you need to absolutely be sure that you can do it consistently, right? So you either need to hire in-house IT and somebody who can really be sure that that's the resource you need to ensure that ability, or a company like ours that is able to supply or support on an as-needed basis and sort of be on call for you. So either way, that's a calculation you need to put into your costs. And then the other thing, again, is that depreciation. So between those two things added up, if it was $12,000 a year for your support and you add in your depreciation, it's about 48 cents per tray in cost there, which leaves you about $7 for design. So planning and design. So depending on how you do that currently, that should be more than enough to cover your design costs when making these trays. So all that comes down to a kind of massive savings for you as a clinic. And hopefully this turns into, this is a huge aspect of why we should be excited, but also, I mean, saving money while improving patient care would be the ultimate goal here. So we're very excited about what this can mean for your clinic. So now we're going to talk about the equipment involved. If you, again, any questions, please let me know. The equipment involved, so you definitely need a 3D printer. The Uni's NB is the fastest printer on the market, up from what was the Asiga, was sort of the gold standard in the past for being the fastest and strongest. The Asiga has 12 milliwatts per centimeter squared of light intensity. The NB is at 16, so it's a significant jump there. And one of the really cool things about the NB is it's a combination of different technologies. So instead of us being limited by the accuracy of a DLP printer in order to get that light intensity that we want, the NB is able to do a columnated 16 milliwatt light source that's sort of backlighting a monochrome LCD. And the ideal thing about that is that LCD printers they're known to be more accurate in the XY direction, what's called the native pixel resolution, because you're having, on a 4K display, you have pixels, the same density of pixels going all the way to the edge of your screen. Sorry, to the edge of your print area. So it's a huge advantage to have both the light intensity that you want and the quality and the sort of accuracy at the LCD level. And then in this printer's case, it's also has liquid cooling. So it's one of the things in the past that's been a big limitation for allowing that type of light intensity with an LCD printer, is that LCDs that operate over 40 degrees Celsius tend to not last very long. And so the NB actually has a liquid cooling system incorporated into it. So it's an incredibly powerful, long-lasting industrial type of printer. And it's also an open source printer, which is huge. As you get into 3D printing, that is one of the toughest decisions to make, because in the past, for most 3D printing specific equipment, by choosing a printer, you're also choosing what resins you can use. And in the end, that's your biggest limitation. So the NB is an open source printer to the point where you can literally create your own material profiles, or it's also pre-validated for over 100 dental materials as is. So very, very advantageous printer to have, and it prints by far faster than any other printer. The next thing you need is the centrifuge. This is probably going to become, in my opinion, the gold standard in 3D printing in dental. So instead of putting it into an isopropyl bath and cleaning all the additional resin off, which sort of exposes all your layer lines and it reduces your transparency and smoothness, the Graphese workflow is to centrifuge it. So it's a heated centrifuge, so it lowers the viscosity of the resin while it's spinning. which allows for even more of the wicking process that we want. And it leaves the product with a very thin, even coat that stays on the outside of it. And the way we're able to get away with leaving that on there is because Graphie has the first nitrogen generator attached cure unit on the market. So they were the first to market with this incorporated. And in fact, as far as I know, they're still the only one where it's truly incorporated like this. There are a couple now that have started to incorporate that idea, though, of having a nitrogen generator available with their cure. It's also tied with the most powerful cure system on the market. So at 200 watts, it is an extremely powerful unit with a larger curing chamber than the NK Auto Flash is sort of the gold standard in dental 3D printing right now for most companies. And again, it's that same wattage, but in our case, we have a larger curing chamber with it's a rotating disc. So it actually more evenly distributes or exposes your prints to the cure. The reason we need nitrogen is because of the oxygen inhibition layer. And when we have oxygen, it basically does not allow us to fully cure that outside layer unless we input some type of inert gas in our chamber. So that's exactly what the TerraHouse cure does. And from there, you need to put it into the ultrasonic bath at 80 degrees Celsius, and then you cool it back down. And from there, you put it into a boil, so boiling water, and then you're ready for packaging and delivery. So this is the sort of unique to this workflow equipment that you have to have. If you don't, most clinics will have some form of a lab with like a handpiece and a workstation. If you don't have that, you would also need that as well. And that's something we can sort of line you out with. It's not a very expensive endeavor to get that going. So now implementation, what would you need to start with in order to begin to implement this in your clinic? And the first concern is going to be design. Like, how do you get the digital aspects of what you need done? And again, one of the huge advantages of using the Graphie system is that you continue to use whichever planning software that you have been using and you're comfortable with, or the design service that you're using, that as long as they're able to, again, produce 3D models. If they're producing 3D models, then those models can be taken into the Direct Aligner Designer software that is a Graphie product that comes free with when you adopt Graphie. And yeah, so you're able to create the trays that you need from whichever planning software you're using. So that's a huge added benefit and just makes it much easier to integrate into your practice. Also, the idea would be to train your in-house staff. So in order to give yourself the most versatility when adopting this product, you want to be able to do as much as you can in-house so that you don't have any delays caused by needing to wait for other people's ability to fulfill your needs. And equipping your staff with that is a significant challenge, but it's definitely doable with the Direct Aligner Designer software. It's something we can definitely help you get there, and if not, just training on that is not too daunting. And then again, just ensuring seamless integration because of that open platform. It's just a really great system to look at. Also, we provide design services from planning to print ready trays with your sort of case planning approval. So no matter what, there's solutions where you can get up and running with this. And then coming soon, there are different integrations that Graphie is working on with their DAD software with an API integration directly with Archform. So you'll be able to quickly go from your Archform to creating those aligners. And then a partnership with Ray Medical. They have the face scan, the 3D face scan that is able to create a 3D image to add into your case planning. So you can combine your CBCT, your intraoral scan, and a face scan all within that planning software, which allows you to plan from your root tips, right? So that's sort of the gold standard coming up next in design.
Mike, we do have another question.
Sure.
How much does the treatment planning cost on average?
I can't answer the average. I don't know that for sure. I would say anywhere from like $200 to $400, I would say, is typical for outside design planning for your case. There isn't really a lot out there in terms of actually designing the trays yet, since this is sort of a new part of it, right? In the past, the design and the planning was just to get to the model, and all the other work happened in real life as opposed to digitally. So that changes the game a bit. That would sort of add a cost on the planning side that you're used to, unless again you bring that in-house. So we charge 189 for the plan itself. And then we can deliver again like a print ready build plate. Essentially, like all you have to do is take that file that we send you, put it on a USB, plug it into your printer, and hit print. So that's sort of the ideal version of design services in the future. And in terms of pricing, I can't give you an exact answer, but I'd say like it's safe to say somewhere around 200 to $400 per case, depending on where you're getting the designs from and how complicated they are. And we can also expect that to not right away, but as time goes on, for that to go down. And I expect AI to get involved in this relatively soon, right? I mean, this is compared to a lot of other lab work. This is a more predictable version of CAD design. So AI will be able to help with tray creation sooner than a lot of other things in the lab space, in like digital design lab space. Hopefully that answers your question.
We have another question.
Sure.
What is the best nesting position for the trays in the 3D slicer?
Yeah, so in the slicing software, with the DAD program, what you're doing is you're taking the models, you're putting them in front orientation, and then the DAD software is going to automatically put it somewhere between 30 and 40 degrees of tilt, if that's what you mean by that. By the nesting angle, I'm assuming is what you mean. And then the DAD software creates your supports so that from there, it doesn't matter what printer you're using, you're just importing an STL file that's pre-supported and ready to be printed. Going a little deeper into that, essentially the higher the product is, the higher the Z axis is, the longer it takes to print. So there's an advantage to wanting to keep it at a less of an angle. But the problem is basically overhang, right? So there's two things. One is the material properties themselves change depending on the orientation that you're nested in. And in our case, being totally flat could be disadvantageous in a material from a material properties perspective, but at any angle, really, we're in good shape in that sense. And then the other thing to consider is the overhang, right? So as anything 3D prints, it can't go too much at an angle per step per layer, otherwise you might begin to have a fall off and lose accuracy. So hopefully that answers your question. So anyway, between 30 and 40 degrees is really what the angle is by default in the DAD software.
He's asking now 80 to 90 degrees. And I think like you're saying you want to keep it shorter.
Yeah,
So
this is more like 30. Well, so 90, it depends on how you're thinking about it. 90 degrees in some sense would be straight up and down vertical, and that would be the longest print time. And also from the material properties perspective, that would not be the optimum. So we want it at a bit of an angle. So between 30 and 40 degrees is something like, from there to somewhere like that. 45 would be like that, right? So that's what I'm saying is like somewhere between here and here is sort of the angle between 30 and 40 degrees is by default where they have it.
Okay, and you may answer this a little bit later on, but we do have a question about which software do you recommend and how do you get training on the Graphy software?
Well, the Graphy software is included. If you purchase the Graphy equipment and everything needed for the workflow, it's called Direct Aligner Designer. And as far as I'm sure there's other software out there that's moving towards having the ability to create the trays itself. I don't believe Archform is able to do that yet, and 3Shape also is working towards it, but not there yet. ClinCheck, I can't imagine them doing that anytime soon. So in terms of training for how to design in the DAD software, the Graphy software, that's something that you actually have to purchase from us. From whoever you buy Graphy from, you have to become certified to use Graphy. And part of that certification process is us showing you, teaching you, and activating your license, your free license to that software, teaching you how to use it to make the trays, teaching you how to slice it in the Uni software, and then teaching you the printing and post-processing workflow. So that's like a requirement from Graphy in order to begin. The question is like, if you have no background in 3D printing, it's probably going to take more than just that initial training to really become comfortable, especially for you and your staff. So that's where the challenge comes in. But again, we'll talk about it a lot, or at the end of the presentation, that's essentially what we are here to help you with, is exactly that, is training your entire staff on all the design processes, the printing and post-processing.
Okay, and we do have another question. The
Sure.
96 costs per case design, does that include refinements? And are they made by an orthodontist or a technician?
It's it's planned by an orthodontist. It still requires your approval. And it's 189 for the planning. Um, and it would include one redesign, one refinement. Um, Again, with Graphy, the ideal situation is that we need a lot less of the refinement cases. But yes, that would be included in our version of our design service. All right. We'll have a lot more time for Q&A at the end as well. So here's a little more about the post-processing process itself, or the printing and post-processing. So this is the unis in action here. If you've ever 3D printed, if you can watch that and see just how fast that is, it's definitely twice or more as fast as the average printer on the market right now in dental. So it's an incredibly fast printer. And part of it is, and one of the reasons why Graphy is only really going to be supporting this printer moving forward, it's not so much that, so the resin itself is validated on multiple printers, but in order to have the fastest results by far, this is the printer. And also for Graphy to best support their clients, they can't be nearly as accurate when supporting many, many different printers, when they're telling you which settings to use and exactly the workflow. It changes from printer to printer. And so they're basically only really technically supporting the NB from this point on. But the NB printer really is just an absolutely, like from an IT nerd's perspective, it's just an amazing, amazing printer. So 25 to 35 minutes of print time, 8 trays at a time currently. There's a possibility of being able to do more later per print. If we start stacking vertically, it'll take longer to print, but you can print a lot more at a time. So it just depends on in your clinic what is advantageous there. And also just as of now, that's not a feature yet, but I could see that happening. So from the print, you're going to take you or your staff will take it from the build plate. You're gonna scrape off the print, each of the aligners onto, we recommend a sheet of aluminum foil. You scrape it onto there, bring it over to your centrifuge, and with all your proper PPE, of course, your gloves, your mask, and your eye protection. And then you're gonna take each of the trays and you're gonna skewer it onto these pins that are located in the centrifuge. The centrifuge can hold up to 16 aligners at a time. So if you have 2 printers going, you can print a client, you can do 16 trays at a time for a client and be able to put them all in the centrifuge at the same time. It's runs for 5 minutes and it heats the air up in there as it's running at 500 RPM. Once that's finished, you'll take it out of the centrifuge. You will remove the supports. They just peel away. They just literally rip off without needing any kind of a cutting system of any kind. And you're going to place it on the tray, the circular tray that goes into the cure unit. Now, at that, you can fit about 8 aligners in the cure unit at a time. You just don't want them to touch, especially, and also you don't want them too close to the center. You want them focused towards the outside, since that's where the energy is focused, and that's why it's rotating. But when you put it in, you can see out of the printer, it's got sort of a yellow look to it. Those are the photo initiators that you're seeing that still remain in that state. And then after the curing process in nitrogen, they're completely transparent, beautifully smooth. It's an awesome process. One thing I do want to mention before you put it in your cure unit, you just always want to make sure that there's no pooling of resin in the tooth reservoirs, like the intaglio side of the device. And worst case scenario, you use like a lint-free cotton swab to remove the additional resin. So now that Graphy released the heated centrifuge, I have not seen that be a problem at all, but it's definitely something to just be aware of. So after the cure, the product is going to be very hot. It goes up to somewhere over 40 C, maybe up to almost 50 C, depending on your ambient beginning temperature. And so just be aware that it'll be quite warm when you open it up. If you are planning to cure another set, as soon as possible, you want to leave the door open to that cure unit and let it cool down to below 20 C before starting the next cure. So you take your trays from the cure unit, and at that point, you're going to polish any of the support tips left over after taking it off, ripping away those supports. The support tips are designed in the DAD software to be like 0.2 millimeters or less. So they're very, very small, which makes it a lot easier to do this post-processing aspect. And polishing tends to just be a handpiece with a 320 grit sanding wheel. And it's, I'd say even less than 2 minutes per tray when it comes to sanding. But it is a very important step, right? Because when it comes to patient compliance, it's absolutely critical to not have any sharp areas or things that are unnecessary that clients will be playing with, chewing on, or playing with their tongue. So it's definitely a very, very important step to pay attention to. And then after you're finished with the polishing process, you're going to put it into your ultrasonic bath at 80 degrees Celsius for 2 minutes. It's recommended to use some kind of ultrasonic cup, like a Branson ultrasonic cup, to not contaminate the rest of the water in your ultrasonic bath while you're cleaning. That way, each time you do this process, it's consistent. It's the same each time. You can do it, just change the water each day, and then let the new water at the end of the day that you filled your reservoir with heat up to 80 C kind of overnight, because it does take an ultrasonic bath quite a while to get up to 80 degrees Celsius. Anyway, so once you have you ultrasonic bath your trays for 2 minutes, take it out of the bath, cool them down with tap water, and then you're going to place them into boiling water for 1 minute. At that point, after the 1 minute, they are very, very malleable when they're that warm. So what we recommend, if you want to keep them for packaging and delivery, if you want to keep them relatively close to their actual printed state, like the shape that they're expected to be in when they're in the mouth, you can add water to your, we recommend putting a small amount of water in your boiling pan on your induction burner so that it boils quickly. And then once it's boiling after 1 minute, you just start adding, tepid water to that. And once it goes below body temperature, it solidifies and it'll stay at the shape that you kind of want it in. And then you're ready for packaging and delivery. And if you've never produced in-house aligners, packaging and delivery, that's not sort of included in the 5 minute post-processing time for this. But with the right workflow, it can be something that can happen very quickly as well. Any questions on the post-processing?
We do have a question.
Sure.
And this is regarding the printer. Which is better, 50, 75, or 100 microns for printing quality?
I mean, fundamentally quality. So let's talk about voxels. All right. So in 3D printing, in normal, we're used to hearing about pixels, right? Which is just the flat version of in the smallest dimension you can get in accuracy for whatever you're working with. And in 3D printing, it's called a voxel. So it's a 3D pixel. And when you do a 50 micron layer, this printer can go all the way to 10 microns, by the way, which a lot of the printers these days are able to do that. But at 10 microns, it takes a lot longer to print, right? So depending on how much you're printing per layer, that increases the time that it takes to print. With the NB, it's basically recommended to go at 100 microns. And it does have a certain amount of layer lines on the buccal side of the front because of the orientation that it's in. That's sort of where the layer lines are most visible or where you can feel them the most. And so you're welcome to go to a 50 micron layer, but you will increase your print time doing that. There's not a huge advantage to going to 50 microns besides minimizing that sort of leftover layer line feeling to the tongue. But it's pretty minimal as it is at 100 microns. It's better than it's probably tied with or better than a traditional aligner already in terms of smoothness. So, and then again, because you're centrifuging as opposed to putting into isopropyl alcohol and sort of almost like etching the product before curing, you will also end up with a smoother finish than you would normally printing at 100 microns, right? So I'd say at the end of the day, 100 microns is the magic number. But if you're worried at all about those layer lines, it's very easy to go to 50 or yeah, it's I don't believe that there's only 50 and 100 in terms of preset material profiles for graphy on any printer that I've seen so far.
We do have another question just about the numbering and the naming on the liners in the
Sure.
software.
So the question is how to do that, or?
It's just, is there a tool to do it?
Yes. So that's part of the Direct Aligner Designer, which is fun to say, Direct Aligner Designer program. And yeah, so essentially we recommend that you export your models from your planning software without numbers on it, because otherwise you're going to get the number put into the aligner in the same way that you get them when you thermoform. So it'll be like an indentation as opposed to an actual like 3D printed number on the outside of the or on the outside of the aligner. So the DAD software has the ability you be depending on the name of the file that you've exported. So it might be like maxillary number 1, 2, 3, all the way to whatever number of trays you have, and mandibular the same. So when you go into the DAD software, you're bringing in your maxillary, however many steps you're going to be creating, and you want to focus on again margin line there. So when you're creating your trays, it depends. You know, you want to do them in batches according to how you're doing your margin line for those trays. And in the Direct Aligner Designer software, you'll bring in the trays, you'll identify the margin line for the trays that you're working on, and then you create the aligners themselves, and then you add the numbers to them, and the numbers get added automatically according to the name of the file. So it's a very fast process to do. You don't have to do it for everyone. You can change the location, move it up and down, and then apply it, and it applies the numbers to all the trays at the same time. So it's directly written on the tray once it gets printed. It's much clearer to read that way. All right. So things to consider when you're bringing 3D printing into a clinic. So, you know, again, the reason that 3DNA was born was because there are a lot of challenges to think about before doing this or while planning the implementation of this into your clinic. So one thing is just choosing equipment and material, right? Like first of all, at this point in the dental market, it's really about choosing material because printers are very comparable for the most part in terms of their abilities and accuracy, not so much maybe in speed, but being able to produce what it is you're trying to do. Printers have a lot in common these days. Materials, not so much. Materials are I mean, they have a lot in common, but it will matter a lot that you have the ability to adopt different materials. So anyway, those are things to consider when bringing 3D printing into your clinic, as well as the infrastructure needed to implement that. Equipment setup and the complexities of the installation and calibration. This is a really important thing to consider because this is probably the step that people who bought into 3D printing early on in dental got discouraged by, right? If it doesn't kind of work out of the box for you, and then it becomes a troubleshooting issue, and then it gets put into the corner, that's what you don't want, right? You don't want to spend all this money and then not get the buy-in from your staff, not get the buy-in from your clinic, and move towards its ability to really help your clinic move forward. So managing that, knowing how you're going to manage that is super important when implementing. A huge part would be learning the digital workflow. We've had several questions already, so you guys all realize that learning how to do this stuff in the digital sense is a massive roadblock, or can be, and you need a solution to learn how to do that in clinic, train your staff, or have a very reliable source for all of those needs. Product understanding, how you understand the usefulness of the different resins that you can print with and their clinical applications. What resources do you have access to in order to make sure that you are on the cutting edge and not taking any unnecessary risk or liability issues? How are you going to deal with IT challenges? Because whenever you're dealing with all kinds of software, being able to create these things in the digital world, you need somebody on your team that can help you when you run into snags, because it's sort of inevitable. As much as this workflow is very proven and it works really well. By the way, 100,000 cases in circulation now for graphy in the world. So very, very proven workflow, but you will always run into IT difficulties when you're implementing digital workflows from time to time. And then there's also the hardware issues. What do you do if you have an actual type of equipment failure or whatever that is? You know, with 3D printing, with any electronics these days, there's a really good chance that your equipment's going to outlast the warranty period, and it's going to function properly for the most part on its own most of the time. But when something goes wrong, how do you fix it? And also physical damage, right? There are if employee accidentally removes the vat but doesn't remove the tray or the build plate from the printer, and it starts to drip on the LCD, or they drop the tray on the LCD, or there's a little bit of material left, of solidified material left in the vat when you start a new print, or something falls in the vat and that build plate comes down and presses on that and cracks your LCD. Those are all things you need to know will at some point likely happen, and you need to have a solution for those things in clinic so that you can really support your clients and guarantee the fact that you can deliver this um, in your clinic. And then how do you stay up to date? Are you passionate about 3D printing, and you just sort of, without needing to try, always kind of stay on the cutting edge of what's going on? Or does that seem like a whole other thing that you need to worry about and focus on compared to just wanting to be a practicing clinician? So at the end of the day, how do you get to being able to scan, design, print, process, and deliver efficiently within your clinic is a massive concern, and you need to know how you're going to tackle these things when adopting 3D printing. So with all the material properties that we've talked about, all the cost savings and all the advantages that Graphy can really give your clinic, here's sort of a synopsis of why we should be excited about the ability of implementing same-day aligners in our clinics. Even if it's next-day aligner, compared to going from a 2-week turnaround to a 2-hour turnaround is just an insane leap forward. And doing that while increasing the patient's experience, like making it better in some sense, in a lot of ways, is just an incredible revolution. So it's also really cool that as you use this product, if and when you have this increased volume, you can scale up really easily just by adding a little more equipment and a little more labor. So yeah, a lot of reasons to adopt this technology in your clinic. So how does 3DNA help? This is kind of where we're getting to really more how our focus as a company and how we want to work with you. So with all those pain points that we've talked about, we supply the equipment and the materials. We don't only sell the NB printer, but again, with Graphy's workflow, it is by far the recommended printer, and the next best printer for this literally takes twice as long per print. And I mean next best in the entire industry. Like the other companies that are coming close to being able to offer this service, as far as I've seen, their print times are around an hour or more. So it's definitely an important thing to be able to get the right equipment and materials, which we're very happy to help you with. We can help with lab design and infrastructure consulting. So we work with you on what space you have. We know how much space the equipment takes up and what order things go in order to have sort of an efficient workflow. And we'll even work with, if you need, when you're implementing Graphy, we need to have pressurized air at the location for that nitrogen generator. We need a sink and drainage and a few other things like particulate vacuums and things like that require power sources. So all these things that need to be considered when starting the lab, we can help with. Again, equipment installation and calibration support. We're there with your staff to do that, help them remotely, or we can also come in person for just the added cost of the travel and stay. And then the in-depth workflow training, right? So that's the biggest concern, is how do you get your staff and your clinic fully trained to be able to do this all in your clinic without the need for outside design help? And that gives you sort of the most, as a clinician, it gives you the most options, right? You can try new things, you can immediately fix problems, as long as you keep as much as possible in-house, and you can lower your cost per tray labor-wise. So we help from design to delivery. We help with all aspects of the training, ongoing and by appointment. So anytime you need more help, we're there for you. We also give you access to Graphy resources. We're creating, it's still very new, but we're creating doctor study groups. So everybody that's working with Graphy, we're going to give you guys access to each other so you can work with each other. And again, as we said, we're looking for key opinion leaders in the US for Graphy. And we'll be putting on KOL webinars, which we will provide to our clients as part of our package. Troubleshooting and IT support, that's in our DNA. That's really that's where we're from as a company. So we're very, very confident in that aspect of being able to help. Remote and in-person equipment repair, again, hardware repair, that's deep within our DNA as well. So that's something we're very happy to help with. And finally, keeping you up to date with the latest in what can be implemented with your current equipment, as well as equipment that might add a certain type of efficiency to your clinic and make you aware of those things and help you implement those things as time goes on. The other thing is, Dr. Kenji has a presentation that we can share with people. If you're interested, at the end of this, we can send you a link to a recording of one of his presentations where he goes more into the clinical aspects of things. But he shows how they're using Graphy's TC80 material, which is their crown and bridge material, to do all kinds of in-house produced expanders and tensioners and all kinds of things that are things we could work towards moving, like adopting more and more in everyone's clinics in the future. So there's a lot of other things that we can expand into from this point on. That brings us to the end of our presentation. Thank you guys so much for attending. And if you have any more questions, this is a great time for it. Please do scan that QR code and set up a meeting with us if you're interested in taking the next steps. And feel free to take down our contact information.
Does anyone have any other questions before we commence? Okay, well, we're both available if you need any questions. And thank you for joining us today. And Mike, thanks for all your knowledge.
Absolutely, guys.
Well, I think I may have one question.
Oh, okay, let's do it.
Well, I think we already addressed this one. It was just about pricing. And we can send out the pricing sheets to everyone after the webinar as well.
Yeah.
Okay, let's see. We got one about Canada. So they want to know, can we provide to Canada?
Yeah, absolutely. I mean, yeah, the best thing is to get in contact. The more you're interested at this point, just get in contact with us. If for whatever reason we can't supply something, we'll do our best to connect you with who can. But yeah, absolutely, to take the next steps, just get in touch with us and we're ready to help.
Does the resin require specific validation?
Well, the resin, so the resin market in dental to be FDA approved obviously requires specific validation, and to be validated to have a class 2 medical device requires validation. Graphy has all those validations already, as well as being CE certified and KFDA certified. So they're already approved in the way that you would need them to be approved in almost most places that you might be. I don't know if that answers the question. There's not like a validation beyond that FDA approval that you need. Besides that Graphy training, in order to make sure that Graphy wants to ensure that their product stays, with an incredible reputation, and that's why they require a training course to make sure that you understand the full process on how to use the resin in the right, with the workflow that is FDA approved.
Oh, and there's a question about ventilation, which we touched upon a little bit earlier.
Yeah, I mean, resins, photopolymer resins have a certain smell to them. Different resins have different smells to them, but mostly they all have some kind of a smell. It's not a super overpowering smell usually, and it isn't like a health safety concern, but probably not something you want to expose your patients to, just because they might wonder what that smell is. So the NB printer has an attached air filtration device that you can purchase in addition. I don't have price on that just yet, but that's something that we can give you if you're more interested. But essentially, it's a carbon filter for that air. And there's also like in-cabin air filters that are sort of add-ons that can work with any 3D printer. So there are definitely solutions to the problem of having that photopolymer resin smell, for sure.
Okay. Well, it looks like that's it, unless anyone else has any other questions. Oh, hold on, we got one. Sometimes smells. Just- Oh, it is just saying, how does the smell these resins compare to other resins on the market or other printers?
Sure. I don't know how to quantify that. I mean, it basically, yeah, I mean, every resin in my experience does have a sort of unique smell, that I usually think of as like my way of identifying which resin's what. But the smell of Graphese resin is I just don't even know how to describe it, to be honest. Like it's not offensive by any means, but it has a unique smell. And um, again, the smells, yeah, the smells tend to come from the materials or the photo initiators, especially used in that, or the mix of monomers, photo initiators, and fillers that are being used. So I don't really have a good answer for like what it smells like. Um, but it's not offensive. It's not something that's gonna affect, your clinic or whether or not to adopt this at all. I don't know if that answers your question. I just don't know how to answer like how it smells in a description. It's relatively minor smell, but it's something that is present.
Okay, we have a question about a specific printer, and I'm not sure how to pronounce this. Is Acureta Soul?
Accurata? Yeah, Accurata Soul. Yeah, so Graphics material is approved to print on Accurata Soul. I want to say they have basically if your printer, if you can go into your slicing software and you see the resin as a validated resin in the materials that you can print, you can definitely print in Graphy on your printer. Again, with Accurata Soul especially, I can tell you you're looking at like about, I'd say anywhere from an hour and 10-minute print time on up, I would expect. But if you're looking to try it out that way, it's definitely a possibility. Um, and just know that like as time goes on, again, Graphy's not going to be updating the support settings and the print settings for other printers besides the NB. So it's just a bit of a weakness. And if you're going to really rely on this in clinic as a long-term solution, it's highly recommended to go with the Uni's NB once you've decided to really adopt it. But the Accurate Soul is a good printer. It's got a much lower light intensity, meaning it'll print a lot slower, and the build volume is quite a bit smaller. Um, but but yeah, it definitely works on it.
Okay, good. Any more questions before we wrap up? And we're always available after this as well. All right, sounds good. I think everyone's asked everything they want to ask.
All
Thank
right.
you,
Thank
Mike.
you guys so much for joining us. We really
Yeah.
appreciate it.
Thank you to everyone. Take care.